So if you're listening to this, I'm guessing you've finally done it. You've navigated the cloud capacity wars.
You won the lottery.
Exactly. You refreshed the browser, you begged the quota gods, and you finally secured it. That golden ticket, an H100 or an A100 instance. So congratulations are in order. You have the keys to the kingdom.
It's a huge milestone. It really is.
Yeah.
But, securing the hardware is sort of where the infrastructure fun ends and the real, let's call it a headache, begins.
Right.
You're just staring at a fresh OS, and the setup rituals you need to go from that bare metal compute to a stable, reliable, fine-tuning environment are, well, they're complex.
I know exactly what you're talking about. That gap between I have the VM and my training script is actually running successfully. That's where people lose days.
Days, and it's an expensive few days.
Yeah, you're just burning through expensive compute time.
Absolutely. So the source material for this deep dive, it gives us this fantastic six-step roadmap. It's like a set of field notes, really, designed to just get rid of that friction. It's all about making the right choices up front, so you can actually train tonight instead of, debugging until sunrise.
Okay, let's unpack this. Let's start right at the foundation, building that core VM. Because the first choices you make, even before you boot it up, they're pretty crucial.
They really are. And let's start with the operating system. I mean, you could use something like RHEL or maybe a bleeding-edge version of Debian, but the sources are really strong on this. Stick with Ubuntu LTS.
Long-term support, so like 22.04 or 24.04.
Exactly.
But why that specific constraint? I mean, can I just use whatever I'm comfortable with?
You could, but you'd be adding a ton of unnecessary friction. When NVIDIA releases new drivers or when PyTorch or TensorFlow release new libraries, they're almost always tested first and most robustly on Ubuntu LTS. If you go for something else, you're suddenly on the hook for translating package commands, dealing with dependency issues.
Right, you're basically on your own.
You're on your own. You're solving problems the community hasn't seen yet. Just stick to the paved road here. It's easier.
That's wise advice. Friction is wasted money when you're paying by the minute for an H100. Okay, so right after the OS, we hit that painful reality of GPU selection and quota.
Ah, yes, the non-technical barrier.
Yeah.
It's a huge one. Because these GPUs are in such high demand, you have to confirm your quota before you even try to provision the machine.
Not at the end of the process.
No, absolutely not. If you wait till that last click and then you see that red quota exceeded denial, you're set back. And it could be days, it could be weeks waiting for approval. So verify your quota first.
Okay, planning ahead saves a ton of time. Now, storage. We need real space. The source material is very clear that, anything less than a terabyte is just asking for trouble.
A terabyte minimum. And that number surprises some people. They think, why so much?
Yeah.
But we're dealing with these multi-billion parameter models. A single checkpoint of something like Llama 270B, even when it's compressed, can be over 150 gigs.
Wow, okay.
So if you want to save a few checkpoints, keep the original model weights, store your data set, you blow past 500 gigs instantly.
So 1 terabyte is just your survival minimum. If you have a big data set or you want backups, you're looking at 1.5, maybe 2 terabytes.
Exactly. It's much easier to size it right at the beginning than trying to resize a live volume in the middle of a critical run.
For sure.
But, if we boil all those core VM choices down to the single biggest failure point, the one thing that will stop the machine from ever even seeing the GPU, it's secure boot.
Ah, yes. The source of so many sleepless nights, you just have to turn it off.
It is mandatory. And it's fascinating to understand why. I mean, secure boot is a great security feature in general, but for ML training, it's poison.
So what's it doing?
It's designed to stop malicious code from loading before the OS. It does that by checking the cryptographic signatures on all the kernel modules.
It's basically asking, do I trust you? Are you signed?
Precisely. And NVIDIA's proprietary drivers, which you absolutely need for H100s and A100s, they're often not signed with the default keys that the Linux distribution trusts.
So the system just says, nope.
It says, unknown vendor, access denied. The driver gets blocked, the GPU is invisible, and you're just staring at an error message, wondering why your brand new, incredibly expensive machine can't run NVIDIA smites.
And the fix is just brutally simple compared to the hours you'd waste debugging. You go into the security settings in your cloud portal and you just disable secure boot before you boot for the first time.
That's the mantra, secure boot off. Okay, so once the VM is configured, we can jump into access and persistence. Step 2 is securing your connection.
Right, so you've added your SSH public key during creation. The sources also mention a best practice here, SSH agent forwarding.
Yeah, and this might sound like a small technical detail, but it's a huge convenience and a security win.
How so?
When you connect with agent forwarding, that's the AA flag in your SSH command, your local SSH keys are sort of temporarily available to the remote VM. This means the VM can access other things like a private Git repo or a Hugging Face using your local credentials.
Oh, so you never have to copy your private key onto the remote server?
Never. No private keys in the VM. It simplifies everything. But, just connecting still leaves a hole, right? Your machine has a public IP and an open SSH port just sitting there.
Exposed to the whole internet. Yeah.
Exactly. So good security posture says we lock that down immediately. The sources recommend using a VPN solution like Tailscale or WireGuard.
So you create a secure tunnel first.
You do. You install Tailscale, you get it running, and then once you can connect privately, you go in and you completely remove the public firewall rule for SSH. It just pulls your expensive machine off the public attack surface.
Which brings us to our lifeline, which the source material covers in step 6, persistence. How do we make sure that multi-day training job doesn't just disappear the second my Wi-Fi drops?
This is the universal truth of remote work, right? Your local connection will fail.
It's a matter of when, not if.
Exactly. So you need a persistent session, and the answer, which has stood the test of time, is a terminal multiplexer. The standard recommendation is screen sessions.
Okay, screen.
Yep. Some people prefer 2MUX, but screen is robust. It's everywhere, and it's perfect for this one job, keeping your process running. It's your safety net. You start your training inside it, Screen A sense training. Then when you need to leave, you detach.
That's C-trial plus A, then D.
And your process just keeps chugging along on the remote server, totally safe from your local network drama. When you come back, you just reattach with Screen SDR training, and it's all right there.
If you don't do this, you're basically gambling thousands of dollars of compute time on your home internet.
Don't make that bet.
Okay, so we've built the VM, secure boot is off, it's secure with a VPN, and we're inside a screen session. Now, step 3, the software stack. Time to install drivers and tools.
Right, and assuming we took the advice and we're on Ubuntu LTS, it's a pretty logical sequence. First, some utilities, Python 3 Ven for isolation, Python 3 Dev, and the absolute must-have dashboard tool, and VTOP.
And then the big one, the NVIDIA drivers themselves.
Right, which, and this is crucial, must be followed by a system reboot, sudo reboot. Don't skip it.
Okay, and when it comes back online, what's the very first thing you check?
It's always NVIDIA Smike. If I see that beautiful table listing all my GPUs with their memory stats, I can breathe again.
And if you see nothing?
My first thought is always, did I forget to disable secure boot? It's almost always that.
Okay, so assuming that worked, the next tool is NVTOP. Why is this so important?
NVTOP is your visibility. It's a real-time dashboard. You can see your GPU utilization, memory usage, temperature. You start a quick test, you pull up NVTOP, and you know instantly if your job is actually using 98% of that GPU or if it's stalled at 2% waiting for data.
It's how you spot bottlenecks before you waste hours.
Exactly. And speaking of performance, you have to isolate the training environment. H100s, they work best with newer CUDA versions like 12.1 and up. You must use a Python virtual environment or Conda.
To avoid version conflicts.
To avoid the disaster scenario where your system needs an old CUDA version for something, but PyTorch needs the new one, isolation is just. It's key to stability.
Okay, isolation check. Verification check.
Okay.
So now we move from compute to data, which is steps 4 and 5. Step 4 is this surprise authentication hurdle.
Right. So many of the best models now are gated. You can't just anonymously download them. You need to authenticate, usually with Hugging Face.
So you install a CLI, you run HF auth login. Seems straightforward, but the sources flag this. 401 gotcha. What's that?
This is such a classic, frustrating quirk. You can log in successfully with a CLI. You can even run auth WOMI, and it says, yep, you're you.
Okay.
But then your fine-tuning script, when it tries to download the model weights, it gets a 401 unauthorized error.
So it knows who I am, but the script can't prove it.
Exactly. The script needs the token set as an environment variable, HF token. It doesn't always read it from the cache file automatically.
Ugh, so what's the fix?
The fix is this critical little command. You manually export the token from the cache file right into your shell environment. That one line of code resolves these mysterious 401s instantly.
That is exactly the kind of thing that saves you 3 hours of pulling your hair out. Okay, moving on to the final friction point, the wait heartbreak of step 5. This is about Git LFS.
Large file storage. And this is arguably as critical as secure boot, but for your data integrity.
Hmm.
If you're cloning a model repo with huge files, you must have Git LFS installed before you clone.
What happens if you slip it? What does Git give you instead of the real model weights?
It gives you a tiny placeholder text file. The source material calls it a pointer file. It's just metadata, like a URL and the file size, something like OIDShed 2TT6, size 13 billion.
So you think you've cloned the model, but you've just cloned a bunch of receipts, and you can't fine-tune a receipt.
You cannot. You need the actual tensors.
Yeah.
With LFS installed, when you clone, you pull the real weight shards. You know, the 3.2G modeled 00001 of 00005.safe tensors files. That's what you need. If you try to train on the pointer files, your script just crashes.
Okay, so that whole sequence drivers, authentication, Git LFS, that's the clean path.
That's the friction-free setup we're aiming for. So now that we've covered the 6 steps, let's just run through that quick pre-flight checklist from the sources before you hit go on that big job.
First, is my access secure? I'm on a private network. Public SSH port is closed. Second, am I inside a screen session?
Don't trust your Wi-Fi. Third, GPU stack verification. NVIDIA Smile lists all the GPUs, and I have NVTop ready to run so I can see what's happening.
Fourth, data integrity. Git LFS is installed, and I've confirmed I'm pulling real weight files, not just pointers. And finally, Hugging Face auth is solid, ideally with that HF token explicitly exported.
And here's one more piece of strategy. Always, always run a short, like 5 or 10 minute test pass on a tiny data set before you commit to a multi-day run.
That's your cheap insurance.
It's the cheapest insurance you can buy. It'll catch any last little config error like a bad file path that you absolutely do not want to find 18 hours into your expensive H100 run.
It's empowering, really. I mean, platforms try to abstract this away, but understanding the sequence, secure boot, drivers, LFS, screen, it gives you the control to troubleshoot when things go wrong.
Which they will. And if you script this sequence, as the sources suggest, you can turn hours of manual setup into 5 minutes of execution on any cloud provider. We've gone from bare metal to a stable, secure, ready-to-train environment. That's the win.
Fantastic. It's an involved process, but it's clearly necessary to get the most out of that powerful hardware.
And, you know, if we connect this to the bigger picture, once your fine-tuning is done, you have a custom model, but now you have to see if it actually works. The process of validation, of inference, is its own complex beast.
A whole new setup ritual.
It really is. And for high-performance inference, you're probably not going to use this same setup. You'll want specialized environments, like containerized frameworks, maybe VLLM or a TensorT running in Docker with GPU support.
Right.
So this raises a really important question for you to think about. How will the infrastructure you just built for training need to adapt or be completely replaced to support the highly optimized, low-latency, production-like environment you'll need to truly test your new model before you ever deploy it? It's about thinking beyond the training run and starting to plan for inference.